very excited about this conversation. We've been having these private conversations, and I thought that we should take some of them to YouTube. Dasan, first of all, why don't you introduce yourself, starting with how did you get involved in the blockchain space, the cryptography space? Did you study it? Did you work on it? Did you invest in it? What's the story?
Right. Well, my name is Hassan Karahan. I am from Zurich, Switzerland, and I studied computer science at ETH Zurich. And the way I got into blockchains and Bitcoin, all this stuff is very early. I joined the entire space as an investor, essentially as a micro investor. I was still a student then, when Bitcoin was at $4 something. And do you remember Mt. Gox, the first Bitcoin exchange?
Yeah, the one that got hacked.
Yes, exactly. That's the one
Where you lost money?
No, I sent just a little amount from Zurich to Tokyo, which took like 3 days to arrive. And the banks cut like 20% on the way there. And then I got my coins and I withdrew them. And a few weeks after they collapsed. So I was kind of lucky. And yeah, that was my initial exposure. Didn't understand really the tech yet. And then I looked into the white paper. And when I read it, I was really excited because due to my education at ETH Zurich, I mean, it was kind of a quite deep theoretical computer science education. I was able to grasp what was going to happen, and also was quite convinced. But I had no idea about the economics and the kind of impact it would have in terms of dollar terms, and was still more majorly tech focused then. Still I am, but now I understand a little bit more of economics. Then a few years later, Ethereum came along, and because they are a foundation also in Switzerland, in Zug, I kind of got interested into that. I became a Genesis investor there. Out of 8,000 people, I was one of the investors who invested with Bitcoin, and it was really exciting what the Ethereum guys were doing, because it was something called how do you say it? Turing complete. You could build smart contracts. I mean, everybody knows nowadays what a smart contract is, but back then nobody had any idea what this technology would enable. All this trading and exchanging. I had no idea what was going to happen. I was just excited from a theoretical point of view that you could suddenly build unstoppable programs, coming from very tech side. But DEXs didn't exist yet, anything. And then 2017, the entire ICO craze happened. Kind of lost half of my Ethereum in investing,
random coins.
They're called shit coins. I don't want to use that term. But still learned a lot in that stage in 2017. What an ICO is, what token economics is, what supply is, how much people allocate to themselves. The entire economics started to making sense to me, and started learning all the terminology. And then around a year later, so the Avalanche professor Emin Günzirer, the founder of Avalanche, on YouTube, and he was telling about his invention how Avalanche will be much faster and cheaper than Ethereum, and I was immediately convinced. And sat down and did like for 2 weeks a simulation of their entire system, simulated their system with like 1 million validators, nodes, and so it was really panning out, at least theoretically. And yeah, and then waited for the ICO like last year for Avalanche and joined that. So nowadays I only invest in, you know, infrastructure coins and coins that really show, how do I say, a technological innovation, and who promise, you know, true decentralization and censorship resistance.
Right. Excellent. Excellent. So this year has been the year of NFTs. What's that?
Well, NFT, I mean, we computer science people, we're really bad at naming things. So if you say, oh, I got an NFT, and your average person has no idea what it is. So what it actually means is a non-fungible token. And what does that mean? You know, non-fungible is an economic concept. 99% of the people don't understand. And the token, people can understand what a token is, but only in a physical form. So let's, you know, unpack those two terms. Let's start maybe with the easier thing. Token. A token is just, you know, a bearer instrument. You know, when you say bearer instrument, nobody understands it. Again, that your average person, but it means literally when you hold it, it's yours. So it's yours. This is true for, you know, this token coins or NFTs, and you own it and you control it, and you can then send this token to anyone via the blockchain. And it's essentially just a piece of certificate, that is under your control on the blockchain. And it is linkable via so-called metadata to an image, for example. And therefore you have this combination. It's a certificate nowadays which has an associated fancy image with it. So that's what it is. But people, you know, discount it. Oh, okay, I can spend hundreds of thousands of dollars for fancy images. That's not the point. The certificate is what you're controlling, and that certifies the ownership of yourself. I mean, ownership in human society, ownership is actually abstract concept. If you go there and you say, look, I own this piece of land, this piece of house, it's a social construct. You know, everyone is going to die. You don't own anything in this sense, but society accepts that you own it. And in blockchain, this piece of token, non-fungible token, accepts that you own that image, which generates value, And the non-fungible part in NFT, which means these NFTs compared to other money, like, you know, rupees or liras or dollars, they're not exchangeable one-to-one. Every image is unique. Every piece of certificate is unique. And that's what essentially an NFT is. And hence, we got this phrase now.
Yeah, one question that, you know, every certificate is unique, theoretically, but you could have 10,000 pieces in an NFT collection, and all of them are sort of exchangeable with each other. Is that true or not?
So now we're coming to the confusing part. The original NFT standard, which is called ERC 721, they're unique in one-to-one, but they're also expensive. They're expensive. But people now, you know, you can have a certificate for a piece of land or a piece of image, but you may want to, you know, fractionalize this piece of image. You want to maybe sell 1/10,000th of an image to one person, and then, you know, creating 10,000 different NFTs and sending them separately to everyone is kind of expensive on the blockchain. To make it cheaper, they introduced a new standard which allows you to immediately create or manage 10,000 small certificates using one smart contract. So suddenly these non-fungible tokens became
becoming fungible,
semi-fungible, and confusing people a lot. But it's still not like, you know, it still doesn't have the same fungibility like a dollar. A dollar is a dollar is a dollar.
or a Bitcoin.
But an NFT is still, associated with something that is not as fungible as a dollar. So now suddenly we had these two extremes, non-fungible and fully fungible. And now the new NFT standards are somewhere in between.
Right, excellent. So, taking this conversation a little forward, what is OpenSea and what are they doing? So they like the Amazon for NFTs?
You could say that they are a market.
Right.
You have OpenSea and you have, I don't know if they support Avalanche, but you have also NFTrade.
Okay.
There are various websites where marketplaces are now popping up, like eBay. I would make more of an analogy to eBay, because Amazon is kind of physical, but eBay, I mean, it's similar. You could say it's an Amazon of NFTs. It's a marketplace where you can list, buy, and sell your NFTs. And you can mint them also.
Right. And so, right now, digital art seems to be the craze with NFTs. But
Absolutely.
Going forward, potentially, even property, other things, physical assets can also turn into NFTs, which are tradable, and then they can be fractionalized, like we have fractional shares. So the whole ecosystem
NFTs,
around ownership essentially can be translated into NFTs, right? Is that the bigger idea?
Yeah, NFTs will become ubiquitous. I mean, NFTs will become company shares. NFTs become credentials to access your own home. For example, your own home may have a smart lock, and your phone will have, this NFT. And if your phone has this NFT, your door will open.
It's like a bearer key. So if whoever has it owns the home.
Ownership house ownership, that will happen. NFTs will become digital identities. With NFTs, you will be able to get to vote. With NFTs will become ubiquitous and everywhere. And today we have the first stage of NFTs will become financial instruments, bonds and stuff like that. So they will become everything in a sense.
So as NFTs evolve into, for example, shares, how will that ecosystem build itself? Now, what's the difference between, for example, having a fungible token or an NFT share in a project?
A fungible token is essentially a sort of money or investable asset. A fungible token. In fungible tokens, there are two distinctions: medium of exchange and store of value tokens. Store of value tokens. Medium of exchange tokens are, for example, stable coins like USDC or USDT. And store of value tokens are like Bitcoin or some sort of digital gold. And these are fungible between each other. Every unit is equivalent to every other unit. But an NFT share in a company that can have additional rules like dividends payments or voting rights or non-voting rights. The entire company share equity market structure is very complex, and all this complexity from this financial world you can map with onto NFT contracts. Right.
So from an, I think, economics point of view, the problem that the whole blockchain, NFT, non-NFT, the whole ecosystem solved is addressing scarcity, right? That pre-blockchain, it was difficult to have digital scarcity for anything. You could have a photograph of an apple and you could have 5 million photographs of an apple, and if air is free, so air is abundant, so it's also free. It's the time when something becomes scarce that there is value to it. So what are your thoughts around the economics of what's happening in blockchain and NFT?
Again, I'm not an economics guy, but what's happening at the moment is a huge hype. Essentially, what we're seeing is art. Nobody would have thought that art will be one of the things which will become digitized and digitized ownership of art. but that's what's essentially happening. And people suddenly realizing, hey, wait a minute. I mean, I can't own a Picasso, but maybe I can own, 1/10,000th of a Picasso. Banksy, there is this artist Banksy, and the Avalanche guys just fractionalized a piece of art of him, and they're going to sell like 10,000 pieces of it as NFTs.
Right, excellent. So you just mentioned Avalanche. There was Ethereum which managed smart contracts. Now we have Solana and Avalanche. What is the key difference between, for example, Ethereum and Avalanche? Why do we need Avalanche?
Well, let me put it this way. You have these token blockchains like Bitcoin and Litecoin and so on, and you have the smart contract platforms, platforms. Ethereum is one, Avalanche is one, Solana is one, and there are others. And why do we need one? Ethereum at the moment, the transaction fees on Ethereum are high because Ethereum has limited capacity. They're trying to fix that with Ethereum 2, but we have been waiting quite a long time for them, to increase capacity. And now these newcomers with new tech, new innovation, started jumping in and offering cheaper transactions for smart contract platforms. And that's one of their benefits. And they have now, they're starting to offering additional benefits, which Ethereum, the original Ethereum, didn't have. For example, Avalanche is going to have subnets of kind of horizontal scaling. It's kind of the scaling, they had this trilemma. You can't have a fast, cheap, and decentralized blockchain kind of hypothesis. Now Avalanche is trying to solve this by offering a cheap transaction platform.
Right. And so what's the challenge with Ethereum's, gas prices? Why are they so high?
Well, first of all, they are decentralized. So they're a bottom-up, grown-up system. They're a bottom-up, grown-up system. And they use a technology called proof of work, which to provide security has to burn electricity, and which is a slow process. And because of this, you have limited capacity of, and blockchains or any database, these are, or money, as Elon Musk recently was talking about, money is an information exchange platform. It's a messaging system. And blockchains are also messaging systems. And it's an engineering product. And the messaging system has capacity. And Ethereum simply has low capacity due to this technology. And Avalanche has a higher capacity. Therefore, the fees are cheaper.
Right. And which is why, a lot of developers are now trying to look at, other than Ethereum platforms to build, because the transaction fees are high in Ethereum. So they feel that they need to move to a different smart contract platform.
Yeah.
It's primarily a question of fees, right? Is that because the ecosystem wise, Ethereum is far ahead of everybody else?
Absolutely, because the Ethereum has the first mover advantage, and people actually accept that Ethereum is decentralized and censorship resistant. And then Binance Smart Chain came along, which was not decentralized and censorship resistant, but people didn't care. Developers said, look, there is a use case here. Let's just move, projects which doesn't make sense with this high transaction fees from Ethereum to Binance Smart Chain. And then Avalanche came along, which is better in terms of transaction fees, but doesn't have still, the same censorship resistance qualities like Ethereum, but they're working on it. So that's one of the things people have to be aware of. It's decentralized, but not censorship resistant yet.
Right. And so explain to me a little bit more about proof of stake and proof of work, because the project that you're working on, XPowerMine, has something to do with that. So why don't you explain proof of work and proof of stake a little bit before we go into that?
Proof of work is, these blockchains to enable security. It's a messaging system. If a transaction, an exchange of value, is a piece of message. which the global community has to accept as valid, as well. And for this message to be verifiable, people use some technology called proof of work, which essentially boils down to burning lots of energy and turning that energy into information and into a signature, which people can then verify using just a little energy, so very quickly. So to sign a message as, look, I am sending one AVAX from my account to your account. No, not AVAX, maybe Ethereum. One Ethereum from my account to your account. I'm burning this amount of energy and using that to sign my message. And people can just quickly check, oh, look, this guy put in this effort, so this message is valid. It's not spam. It's not, spoofed or, fake. And people can verify it quickly. So this allows people to establish a decentralized messaging platform, transaction system, blockchain. And proof of stake doesn't use energy. It uses money. It uses money. So people say, look, I'm rich. I am rich, and I am signing this transaction to be valid. And people trust there that people who are invested into the ecosystem of, for example, Avalanche, proof of stake systems, they will not cheat. They will not cheat, because if they would cheat and sign fake transactions, then the AVAX value would collapse and their investment would evaporate. So there's that link there.
Right. So let's answer this question from Salman first. What can you expand a little bit on censorship resistance?
Censorship resistance is, when nobody on the planet has the ability to stop your transaction, your message from getting processed. Right.
And in Avalanche's case, that capability is less.
Yes.
Why is that?
Absolutely. Absolutely. In Avalanche, there are about 10 validators, which, if they would come together, would be able to censor your messages. But they have the nice thing about Avalanche, I love Avalanche, by the way. I'm a big fan of Avalanche. I'm a big investor there. The reason I'm so convinced of Avalanche compared to, for example, Binance Smart Chain is you can distribute this stake, this AVAX, to a wider and wider and wider circle over time for it to become more and more the censorship resistance. So at the moment, the number of people who can stop your transaction is about at 10 validators. Although I have like 1,100 validators, the top 10 or the top 10 control 30% of the stake, and the top 70 control like 70% of the stake out of 1,100 validators. But you see, in Bitcoin, it's not really better. For example, in Bitcoin, you have like 24 mining pools. If these pools would come together, then they would be able to also censor you. But Avalanche has the option to extend the validator subset, which can censor you over time by simply distributing money.
Right. And the possibility of staking pools emerging in Avalanche ecosystem is less, or is it also there?
You don't need staking pools. You don't need staking pools.
Right.
In Bitcoin, mining pools emerged because a single miner was not simply able to, mine in a, reasonable way. So they had to pool together their energies to set up these pools. But in Avalanche, you don't need that. Every validator is, at the moment, even the smallest validators, they are validating and signing messages as valid or invalid. But the smaller validators, signature, whether a validator is valid, whether a message transaction is valid or not, is counts less because they are a small validator.
Right, absolutely. So tell us about XPowerMine. What is it? What is the plan?
XPowerMine is kind of, I'm a big Avalanche fan, as I said, but when I realized that, at the moment, only 10 validators are controlling it, I became a little bit frustrated because I wanted to have a system which, the problem proof of work people tell proof of stake people, look, proof of stake is great. It's energy efficient, it's fast, but it necessarily has to start from a centralized point of view. The system founder has to set up, has to mint all the tokens, and has to distribute them, So it necessarily starts from a centralized fashion. But proof of work people are all a little bit insincere here because Bitcoin also started in a centralized fashion because the first miner, there was only one miner and his name was Satoshi Nakamoto, and he was controlling the entire system. So both systems have actually, a similar problem. Now with XPowerMine, I said, look, maybe I can use the inherently more distributed nature of proof of work systems using a smart contract on Avalanche where people mine and mint XPower tokens on Avalanche, and we will use these tokens then to set up our own subnetwork, and we hope to achieve a distribution where a larger set of validators control the XPower tokens. So it's more censorship resistant.
Right. So what you're saying is that this will allow a broader distribution of the token?
Exactly, because electricity inherently is more distributed, so it will lead to a better distribution. But in XPower, you need two things to mine the token. One is electricity, CPU power, mining power, and the other one is AVAX, to mint the actual token, And at the moment, the minting cost is dominating the mining cost. So mining cost. Therefore, I'm not that different at the moment from, if you have lots of money, you can mint lots of tokens and you end up in this situation. But the more popular XPower gets, the more miners will start mining using electricity, and this cost will start dominating. The hope is that over time it will get more distributed.
Excellent. So
distribution of tokens. Everybody tries to, establish a wide distribution of the tokens. Every, blockchain, every token, every project, because if you have a token which is in a single hand, it doesn't make sense.
Right. And so in terms of distributing it to a wider audience, a lot of projects have focused on mining and which leads to somebody being either previously involved in the crypto ecosystem. So are there any also projects which are focused on non-participants of the current system and bring them on board?
Yeah, I mean, there are projects. One of the projects I saw, I don't remember its name, they were like going in Africa into villages and taking biometric data of people, like their iris scan. And
I think Sam Altman's project, I think.
Yeah, they were giving in exchange tokens. So in exchange token, but that's a centralized operation. So the guy who is distributing the tokens has able to flood the market with their own tokens. In XPower, I don't have that power. Although I set up the smart contract, you can go and read it. You can verify that I can't mint any tokens out of my pocket because you need electricity and AVAX.
Right. So I think there's a question from Sidra, which is, can you also shed some light on how interoperability in blockchain would change the overall transaction structure of any cryptocurrency? So essentially, I think interoperability between blockchains and
there are two approaches to this. One, I mean, one is you will have just totally different blockchains and they will interoperate through economic markets, exchanges essentially, and decentralized exchanges. That's one form of interoperability, exchange of value. The second form of interoperability is what the Cosmos project is doing. It's kind of a toolkit to build blockchains. And if there are many blockchains out there who are built on this Cosmos toolkit, and these blockchains, they can communicate with each other because they're using under the hood the same technology, but they're kind of limited to, like, each blockchain is kind of limited to 100 to 200 validators max, but that might be enough for a lot of use cases. So that's one form of interoperability that's limited. And then you have the Avalanche model of interoperability, which is unlimited, which I really like, which they call subnets, where, you know, anybody can start their own Avalanche subnet and, you know, incentivize their own validators for their own use case. And then they can use the Avalanche platform chain on the mainnet to talk with each other. And this will be inherently more scalable due to the better technology of Avalanche, essentially.
Okay, excellent. So Ahad wants to know, can you please explain the chains in AVAX? An example of each would be quite nice too.
Yeah, so in Avalanche, you have to, so first of all, let's distinguish. Avalanche is the name of the chain and AVAX is the token on the chain.
Yeah.
And in Avalanche, at the moment, there is one network of 1,100 validators. And this is called the main network. And within the main net, you have three chains: the platform chain, which coordinates things, the exchange chain, the X chain, which is a fast chain to exchange AVAX, very cheap, cheaper as the C chain, the contract chain, which is the smart contract chain, which is still cheaper compared to Ethereum, for example. These are using three different so-called virtual machines, you know, pieces of virtual kind of, virtual CPUs, you could imagine like that for a non-science guy, which offer these services. So these are the three chains. And now what is coming is subnets, you know, next to the mainnet, people can start their own subnet. For example, I plan to start my own XPower subnet at some point of the project, where I will use XPower tokens to power my own Avalanche subnet. And if I want to communicate from my subnet with other Avalanche subnets, I have to go through the main network, which is, by the way, this entire structure is being built, fleshed out by the Avalanche team.
Oh, that's very exciting. So that means that if there's a transaction happening within the subnet, then it won't carry an AVAX fee, correct?
Yes, you can use your own token. You can use the technology from Avalanche. They're working hard, so people can start cheaply in an easy fashion their own sub networks, and they're betting that once people have their own subnets, so, you know, Deloitte has their own subnet, I have my own subnet, or, you know, governments have their own subnets, CDBDs have their own subnets. Then they will start, okay, I want to talk with other subnets. So the Avalanche founders, the Avalabs people, they are betting that then they will use the mainnet to communicate with each other.
Right.
And in that case, they have to go, they have to get AVAX. That's the kind of, so they're giving people the freedom to do whatever they want in their subnet, and then saying, but, you know, if you go through us to interoperate, then you have to use AVAX.
So is the technology to launch your own subnet available right now? Yeah.
Yes.
It's going to be, it's being developed. It will be available later.
It is available, and you can use so-called, you have to distinguish between permissioned subnets and ad hoc unpermissioned subnets. A permissioned subnet is where you say, look, this guy and that guy, they can become a validator, nobody else. Some people need that. A company might need that. You know, they say, oh, look, I want to start a subnet which only operates in the US or in Pakistan or in Turkey or in Switzerland. And or you can say, look, I want to, for example, XPower, I want to have an unpermissioned subnet where anyone with enough XPower can join the network and become a validator.
Right.
And they're working on the unpermissioned subnet technology right now. Essentially, it will be just a copy-paste kind of the mainnet. So people can just with a button, maybe in the wallet, create their own subnet and then start inviting validators to their subnetwork.
Right. And if you were to look at subnets in Avalanche versus what is possible in Ethereum or Solana, which is similar, or is there nothing similar?
No, that subnet technology doesn't exist in Ethereum. It doesn't exist in Solana. These are single use case smart contract platforms only.
Right.
Only. And Avalanche's kind of secret weapon are these subnets. So far, Avalanche is just cheaper and faster, and they essentially copy pasted the entire Ethereum technology.
Right. Right.
Okay. And their selling point was, look, we are faster, we are cheaper. Good. We might not be as, we are also decentralized, which is also true, but they may not be as censorship resistant, like for example Ethereum. But they're going to say, look, we are going to offer you also this subnet technology, which you can use for your own purpose to start your own tech stack. And later on, if you want to interoperate, you might want to use our main network.
Oh, that is almost like the difference between a BlackBerry and iPhone, because this is almost like letting other people build their own, little nets, almost like applications which don't have to pay gas fees in order to operate their own ecosystem.
Yeah. So they call this horizontal scaling, which is really
right.
Going to keep fees on the main network low, because once an application becomes really popular, they can afford to start their own subnetwork and migrate their stuff to the subnetwork and take away load from the main network, and the fees on the main network hopefully will remain reasonable and don't go crazy like on Ethereum.
No, this is very exciting. I'm very excited about this because, from a developer perspective, I think this was one of the issues. If you're building anything and the gas fees are so high or they keep, and there's a lot of variance. So you keep wondering, how it will work out on your platform.
I'm really I'm criticizing Avalanche due to the stake concentration, but I'm really, really excited about their tech. It's really good. They are offering a vision with horizontal scaling where people can do whatever they want on their own subnets. And there is a decentralized exchange, Pangolin. They are going to start, for example, their own subnetwork, and they're going to introduce some innovation. So far, there is no decentralized exchange which offers KYC. Therefore, institutions cannot join decentralized exchanges because they need KYC. I don't like KYC very personally. I detest it. But I mean, if your government says, look, to your institutions, you cannot join any KYC-less decentralized exchange, then it becomes necessity to offer that service. And I welcome that option that people on Pangolin, institutions on Pangolin, will be able to provide huge amounts of liquidity where people can trade them, using very little slippage.
Excellent. Great. Hassan, this was an excellent conversation, a lot of learning for me, and I'm sure for the participants and also for our YouTube audience. We're hoping to have this conversation the same time on Fridays, and we'll be live on YouTube, and we'll invite other guests as well from ecosystem, working on ecosystems like Avalanche and Solana and Ethereum. One thing I would request anybody who's listening in is that I'll put a link on our YouTube video from where you can sign up if you'd like to participate in any NFTs projects that we're collaborating on. We're building fellowships and bring people together to build these projects, and we'll be very excited to hear from you. Hassan, would you like to say something in the end?
Yeah, we XPower, by the way, offers also NFTs. So as a side.
No, no, absolutely. So, in fact, next time, I think what we can do, one of the things we can do is you can do us a demo of XPower, how to mine and mint
Absolutely.
XPower, and also, how does it convert it into an NFT, and how the whole ecosystem, comes together.
Yeah. Okay, great. Okay, thank you very much, John.
Great. Thank you. Thank you, Hassan.
Okay, have a nice day. Bye-bye.